Hello student. So today we are going to discuss about the pin diagram of 8255 PPI. So first of all, port A means port A, that is PA0 to PA1. So these pins are the data lines for the port A. These pins are equally distributed on both sides of the top of the 8255 IC. The keys 1 to 4 and 37 to 40 are the pins devoted for port A. Next, PB0 to PB1. These pins are the data lines for port B, and the keys 18 to 25 are the pins that carry the data for port B. And PC0 to PC1, these pins are the data lines for the port C. The keys 10 to 17 carry the data bits of port A. Among these, the pins 10 to 13 are the port C upper pins, and 14 to 17 are the pins devoted for port C lower. Then D0 to D7, these pins carry the 8-bit binary code which is used to instruct the working of the entire IC. These pins together are called as the control word or the control register. The keys 27 to 34 carry the contents of the control word. Next, A0 and A1. So these pins decide which port will be selected for transferring the data. These keys are present at pin number 8 and 9. So if A0 and A1 are 0, then the port is port A. If A00 and A1 is 1, then it is port B. And if A0 is 1 and A1 is 0, then it is port C. So it is an active low signal key which puts the IC in reading mode. It is present at key number 5. Next pin is write bar pin or WR bar pin. It is an active low signal key which puts the IC in writing mode. It is present at key number 36. Next is CS bar. So it is also an active low signal key which is responsible for chip selection. The key number 6 is devoted to chip select key. Next is reset. This key present at 35 number. When in set mode, reset the entire data present in all the keys to their default value. Next is ground. So there is one ground key for 8255 IC present at key number 7. Next, VCC. The VCC key is from where the IC receives the 5-volt input. It is present at the key number 26. So this is the ADC interfacing with 8255 PPI. So this is the diagram. The ADC 0808 is 8 channel 8-bit ADC chip. It has 8 analog inputs, that is IN0 to IN7. So one of the channel is selected by sending the address to a address line of ADC. Next, the program for ADC interfacing. So first MBI A,98H, that means load the control wire 98H of 8255 in accumulator. Next is out 03H, that means write the control word in control word register and initialize the ports. Next is MBI A,08H. So send the start of conversion signal through PC3. Next out 02H, that means PC3 is high. MBI A,00H, as PC3 will be high, for 1 or 2 clock pulse, make it 0. Next out 02H, that means PC3 becomes low. Next loop IN02, that means read end of conversion signal. So next instruction is RAL, That means rotate the accumulator to check either the conversion is over or not. So next is JNC loop. If conversion is not completed, then jump to the loop. Next is IN00. So read the digital output of A by D converter, that is analog to digital converter. Next CMA, that means complement of ADC output. Next LXI H,8100H. So load the HL pair in 8100 memory location. Next move M,A. Store the accumulator content in 8100H location. Next halt. Halt means to stop the program. So this is the program for interfacing of ADC. So the analog signal is connected to channel 3. The digital equivalent data D0 to D7 is connected to PA0 to PA7 of port A. The PC0, PC1 and PC2 lines of port C are connected to channel select address line of 8255. PC3 is connected to SOS, that is start of conversion, and ALE signal, that is input signal. EOC means end of conversion, which is an output signal of 8255 connected to PC7 to port C. Next, DAC interfacing with 8255 PPI. So this is the diagram for DAC interfacing. Let us discuss. So follow the initial 3 steps of interfacing of 8255 with 8085 that are explained before. The DAC 0808 is 8-bit digital to analog converter IC. It converts the digital data into equivalent analog current. Therefore, 1 to V converter is used to, therefore I to V, that means current to voltage converter is used to convert the analog output current of DAC to equivalent analog voltage. PA0 to PA7 pins of port A are connected to D0 to D7 pins of DAC. In above DAC, dual power supply of plus or minus 10 volt is applied with the reference voltage 10 volt as shown in the diagram. So according to the theory of DAC, equivalent analog output is given as V equals to 0, that is V reference. For example, if data equals to 00H, V reference equals to 10 volt and V0 equals to 0 volt. Then if data is 80H, V reference equals to 10 volt and V0 equals to 5 volt. The control word format of 8255 for above interfacing is given as control word equals to 80H. Next, the program for DAC interfacing. So first instruction is MVI A,80H. That means initialize the 8255 as port A in output. Next, out 83H. That means write the control word in control word register. Next, MVI A,80H. Send the digital data to DAC for conversion. Next, out 80H. That means send the port A for input into DAC. So next is halt. That means stop the program. Next is interfacing of 7-segment display. An output device which is very common is especially in the kit of 8085 microprocessor, and it is the light emitting diode consisting of 7 segments. So moreover, we have 8 segments in a LED display consisting of 7 segments, which includes the consisting of character 8 and having a decimal point just next to it. We denote the segments as A, B, C, D, E, F, G and DP, where DP signifies which is the decimal point. Moreover, these are LED or together a series of light emitting diodes. We have shown the internal circuit comprising of a display of 7 segment. So a 7 segment display is shown in the figure. So this is the figure of 7 segment display, LED display. Next, generate square wave on all lines of 8255 ppi. So the program is like this. First, MBI D comma AAH, that means load 10101010 into D. Next, rotate move A comma D, that means load D to A. Next, RLC, that is rotate accumulator to the left. Next, move D comma A, that means store the accumulator, means value of accumulator into D again. Next, ANI01H, that means mask the accumulator with 01H. Next, out 10H, so send the output to port 10. Next, JMP rotate, that means jump to rotate for next page. Next is design interface a traffic light control system using 8255. The 8085 microprocessor is a popular microprocessor used in industries for various applications such as traffic light control, temperature control, stepper motor control, etc. So in this project, the traffic lights are interfaced to microprocessor system through buffer and ports of programmable peripheral interface 8255. So the traffic lights can be automatically switched on or off in desired sequence. The interface board has been designed to work with parallel port of microprocessor system. So the program is first MBI A, ATH, that means initialize 8255 port A and port B. Next is out 83H, that means in output mode. Next MBI A, 09H. Next out 80H, that means send the data on port A to blow R1 and R2. Next MBI A, 24H. Out 81H, that means send the data on port B to blow the G3 and G4. Next MBI C, 28H, load the multiplier count 40 for delay. Next call delay, that means call delay subroutine. Next out 81H, send the data on port A to blow Y1 and Y2. Out 81H for port B, that means send the data on port B to blow Y3 and Y4. Next MBI C, 0AH, load the multiplier count 10 for delay. Next call delay. Next MBI A, 24H, that is out 80H for port A, send the data on port A to blow G1 and G2. Next MBI A, 09H, out 81H for port B, that is send the data on port B to blow R3 and R4. Next call delay. Next MBI A, 12H, out PA, that means send the data on port A to blow Y1 and Y2. Next out PB, send the data on port B to blow Y3 and Y4. Next MBI C, 0AH, load multiplier count 10 for delay. Next call delay, that is call delay the subroutine. Next JMP start, delay subroutine. So LXID, that is count, means load count to give 0.5 second delay. Next back DCXD, that means decrement the counter. Move A, D, ORAE, that is check whether the count is 0. Then JNZ back, if not 0, repeat. DCRC, check if multiplier 0, otherwise repeat. JNZ delay. Then RET, that means return to main program. So this is all about chapter 5, that is interfacing, memory interfacing. So I hope all are understanding this video. Thank you.